Good morning, everybody who came to our panel discussion. Its title is The Triple Helix and Rise of New High Technology Industries. I would stress special attention on these new high technology industries. It's becoming actually a very hot topic in Russia, as everywhere in the world. Actually, attention to new industries and new industrialization, high technology industries goes in waves, and probably with the rise of new industries. And now we have exactly that time, which maybe started at the beginning of 2010s. And we see this process in different countries. Like in the United States, they started advanced manufacturing partnership. In Germany is studied widely program Industry 4.0 with attention to cyber physical systems. China wants to become more independent due to development of new industries and so on. Actually, this question is really important because industry is what contributes a lot to the gross national product, to export in many developed countries. Also, it's now about new model of organizing the whole manufacturing related to the words probably you heard a lot already, like mass customization and localization, reshoring. It's more related to developed countries. And we today, the panel, have a very interesting group of speakers who will talk about different aspects of this phenomenon. And according to the title of our panel, we have to match it with theory. And I see this match in new composition, new relationships which may arise due to new industries between these actors like government, industry, and universities or science. We have keynote speaker who will present situation and comparative perspective, and we have two other more specific presentations. I assume one will be about biotechnology, more in biotechnology industry, and one about more focus on what's going on in R&D in firms and firms level. So our first keynote speaker is Slava Radoshevich. He's Professor of Industry and Innovation Studies and acting Director of School of Slavonic and East European Studies and University College London. And title of his presentation will be Technology Upgrading and High-Tech Industries Between Myths and Reality. Slava?
Thank you, Irina. This is a kind of World Economic Forum style of setting. And I didn't expect that, so I prepared a kind of PowerPoint presentation, which you wouldn't believe has 36 slides. So, but it's not. We'll omit maybe 20 of them. So don't worry. No, I'm the one who basically like to stick to timetable. So Irina, you will just tell me a few minutes before, or how much I have. 20 minutes, let's say 30. Yeah, okay. So my idea here is to set the scene, so to say, in relation to the topic of this presentation. And I have to state from the beginning what is the kind of my particular angle. I work on, largely in my career, I worked on Eastern Europe. That's where I come from. And I'm talking about the high tech. So therefore, you're not going to listen speech from UK, from US Berkeley professor who will talk to you about Silicon Valley. So therefore my angle will be really looking at the whole issue of high tech from a more angle of middle income economies, which means that I will very much highlight the importance of structural differences between high income, low income and middle income economies, and will give you that type of perspective. And I think it's quite useful because you will have lots of kind of Silicon Valley type of views on high tech. What I want to talk about basically 4 issues. And if you get lost where I am, or if I get lost, then we know that there are 4 issues that I want to address. First is I want to say something about the relationship between high tech and growth. There's nothing new there that you will hear from me. It's just setting the scene, how economists look at that relationship. We cannot ignore it and jump into a kind of policy without understanding what are the broader ramifications. Second, I will go through a set of some findings from my own research, which look at the new technology-based firms in Eastern Europe, and will highlight the differences between new technology-based firms in this part of the world and, as we know it, in the frontier countries. And because I'm in Russia now, I also want to say something about the Skolkovo, because I'm working with my PhD student on a probably first academic paper on Skolkovo. Here we are. And I want to put Skolkovo into that perspective, and then finally conclude with some kind of policy issues. Well, what is the policy implication of that? For those of you that will completely get lost or want to know where I come from, here is the list of background papers from which I kind of had taken it. Either my previous papers or current work in progress. If you need anything of this, please come or email me, and I'll be happy to send you. So first, let's go on this relationship between high tech and growth, because there is this simplified assumption which policymakers often have: oh, the more high tech industries we have, the better it is for the growth. Yeah. But then when economists look at that relationship, then they see that it's a bit more complicated. They see that there is no kind of strong relationship between the share of high tech and economic growth. They see that there is a technological change which goes through all sectors, not only through high tech. There is a increasingly high tech element in low tech industries. The whole distinction between the high tech and low tech is actually becoming more and more blurred. And what we are actually facing is not so much the high tech as independent source of growth, but we see the internal transformation of low and medium tech sectors which have increasingly high-tech elements. So if you are trying to find the answers on this issue by looking at the simple statistical classification and telling these are high-tech sectors, you're on the wrong side of the street, so to say. I will not complicate further with this, and I think that that's enough for the beginning. Second point is that there is also a simplified assumption of the more we put money into R&D, there will be more effects on the growth. And indeed, there were some economic theories like endogenous growth theory which explicitly assume that. Of course, assume that it will be some probability process by which that R&D will lead to growth, but eventually that was the point. Again, empirical evidence is not very supportive of that. Much more, for me, realistic is to think in terms of theory which is today quite in fashion. This is so-called Schumpeterian growth theory, where basically you assume, yes, R&D intensity is quite important, but then there is always some probability whether that R&D will lead to innovation. There are countries throughout the history which invested a lot in R&D. I work in Britain, and Britain was known for a number of years as a country very good in science, but not much happened in terms of innovation. French call it le mal britannique, British disease. That was the call, Or there was example in the past of Japan. He didn't invest in R&D, but was doing quite well in terms of economy. So that is a much more complicated relationship. Second is that also the extent to innovation which will lead to productivity is not something which is kind of also deterministic. You may have innovations in terms of technological kind of novelties, but they do not necessarily lead to higher productivity. Finally, we are in Russia with the history of the Soviet Union, where there were lots of on the shelves R&D output, so to say. Did they lead to productivity? No, because it's all much more complicated. So we see that this kind of complex relationship leads to something which people call paradoxes. And there are several paradoxes in literature. People talk today about the European paradox. What is a European paradox? We invest into science, we have the papers, but we are not like Americans. Then Swedes can also complain. They're also investing a lot into that and not much effect. So people talk about the Swedish paradox. Some colleagues are talking about the Norwegian paradox, poor innovation effort but good economic performance. We have here a colleague from Norway. Then a colleague recently wrote a few papers where they talk about Scottish conundrum. I'll not explained to you what it is, but this is even much more complicated. I think why, Scottish conundrum, not because of politics, but entirely in terms of technology, doesn't lead to growth. So all these kind of paradoxes actually from the perspective of what I said before, from the perspective of Schumpeterian growth theory, are not actually paradoxes. They just show that there is a complex relationship between R&D, innovation, and growth. Of course, then they look to us like paradoxes, but in fact they are a reflection of the complex reality. What we find in life is something much more simpler. We find models like this. This is something which I haven't invented. I was working in Slovakia on this smart specialization strategy, and then we started discussion with policymakers, which now have to spend a few billion of euros, huge amount of money. And we said, okay, what is the idea behind? They said, this is the idea. I said, how do you mean? Research development leads to innovation, which leads to competitiveness, which leads to economic growth, which leads to employment. I said, but we are in Slovakia. You've been growing for the last 20 years based on FDI. Where is FDI in this picture? Well, exactly that's the problem. We are dual economy. We don't want to grow based on FDI. We want to have a new sources of growth, so therefore we want to invest into R&D. I said, but you cannot forget elephant in the room. Elephant in the room is someone that your productivity and growth was based in, so you have to bring it into the picture. So, of course, then we have to kind of scrap this kind of graph, because it will be very difficult to imagine Slovakia growing entirely based on few billions of euros invested into R&D without looking at its current sources of productivity growth. And to show you basically a few figures, just to show the complexity of the world, we usually think about R&D only as R&D figures. But there is R&D which is also embodied in the machinery that countries import. There is R&D which is embedded in the inputs and they're quite sophisticated pieces of equipment or materials. And if you take that R&D which is, so to say, indirect R&D embodied, and if I take, let's say, here data for UK and Bulgaria, then you will see here, could I show here, is there a laser? No, there is no laser. Oh, no, okay. You see this blue part of the bar, which is UK, which shows that out of total R&D expenditures, where you take direct and indirect R&D, you see how UK has a higher share and how Bulgaria has a small share. But when you take the R&D which is embodied in imported inputs, which is this is this yellow? No, sorry, green. Or if you take R&D imported in capital goods, which is this on the top, then you see that actually Bulgaria has a highly sophisticated equipment. It has the same degree of sophistication of equipment as UK. So therefore the issue is what Bulgaria does with that equipment. Is it able really to adapt it and to increase productivity based on that? So we see that there is a lot when it comes to technology which is related to the other aspects of R&D which are not directly your investment. An extreme example of that would be when you take IT sector. Because in IT sector, if you take a country like Estonia, which is here on the left-hand side, whose own R&D in that sector is very, very small. But when you look at the overall R&D, when you take the R&D which is embedded in inputs, in capital goods in that sector, then Estonia is actually very high in that respect. So there is a lot in terms of technology that companies have to master by simply importing that equipment and trying to work on that equipment, which is also, when you take the innovators in Eastern Europe, and this is the whole Europe, from Norway on the left-hand side to Bulgaria on the right-hand side, and this is the share of non-R&D innovators compared to R&D innovators which are on the top, and you see that most of those companies which are innovating in this part of the world actually non-R&D companies. So they do invest in innovation, but they do not necessarily invest into R&D. But then it's surprising when you look at the share of turnover which comes from innovation in these countries, and you look at the new countries and the old countries, and you see that the share is the same. So you say, well, these countries are also investing, they're also innovating. Yes, but this is innovation without R&D, so people are working on something, but this is not necessarily full of R&D. And when you ask yourself what it is, then you take here the share of on the left-hand side, on vertical is GDP per capita, so it's a level of development. And on the right, on the horizontal line, is the share of expenditures for acquisition of machinery, equipment, and software in total innovation expenditures. So that means how much of innovation expenditures is going on simply buying equipment, because this is also something which lead to process and product innovation. And of course, then you see again Bulgaria and Romania there on the far end. So when it comes to innovation, In these countries, it is all about the acquisition of machinery and trying to work productively on deported equipment. And there is a very low share of the, so to say, intangible component of that. That intangible component is there just to make sure that, that I'm productively using that equipment. But that is a not kind of simple fact, and we say, oh, poor them, they should invest more into R&D. No, this is something which is the driver of productivity and which should be concern of policy and with our topic today. Also, when you look at whether these enterprises are using IPR, because it's all R&D, high tech is about the IPR, then you see that actually most of them are basically not dependent on IPR. And I'll show you later on the figures for new technology-based firms, which will illustrate something similar. So I started with this model from my Slovakian colleagues. You remember, starting from R&D, going to productivity, yes? But when you actually look at this picture in reality, then actually that process of growth, of upgrading, should be slightly different. The reality is such that you shouldn't start from the R&D. You should start here from production capability, from the fact that first these countries have to produce at the world levels of productivity. And I've done before some econometrics work where we showed that basically the variable which is significant in explaining productivity growth, you will be surprised which one? ISO 9000 certificates turn out to be significantly related to productivity growth in these economies. Why? Because this is the area where productivity is crucial. Being plugged into global networks and working productively on that. So stories should start from production capability, not from R&D, and then you can talk about the next stage, which is product and process engineering, where you have incremental innovations with not much R&D, which is dependent on what engineers are doing on the shop floor level. And then you can talk about the advanced development for manufacture, if it is possible. And then you talk about exploratory development, prototypes, new products, applied research. But there is a huge kind of process to be mastered in this, and there are also gaps between these different stages. They do not go kind of in a nice linear fashion. So if you think about the possible more realistic kind of a picture, I painted here something which probably you will not be able to see it here because it's too much. I want you just to look at the bottom part where I basically highlighted this process where you go on the right-hand side from production capability, process and product engineering, advanced development, exploratory development, applied research, basic research, and then pure science. Because very often, basically, basic research is directed towards specific broader area. It should be distinguished from the pure science. It's not my invention. This is from the late Alice Amsden part of it. I've just added the missing part of the picture. What are policymakers primarily concerned, especially in EU, is this bit in the middle. Because they're all concerned with the how do we turn our applied research into developments or the other way around, but it's all about the middle. But where the productivity growth comes in most of these economies and in many other EU economies is actually this right-hand part. It's this process and product engineering, advanced development, and the gap between moving to other side of that is quite big with different type of capacities. And this, I put this because I think if we are talking about the high tech, one has to have that picture in mind. And especially when people are throwing billions, then they have to have a more realistic picture. Now, I want to talk now about the second part, which is the new technology-based firms, because these are those animals which are behind these figures. These are those also type of companies where there are high expectations that they will be high growth firms which will drive the growth of the economy. So there is expectation that there will be commercialization of new knowledge, and that will bring about structural change. And what better country to talk about it than Russia? Yeah? So, but my argument would be that it's unrealistic to expect of new technology-based firms to become high growth firms. Why? Because growth of firm is actually something which economics jargon is called random walk. It's accidental variable. You don't know whether your high-tech firms or your low-tech firms will grow. There is no kind of, economists have done a mass of research trying to understand that, and it is not possible to target kind of specific group of firms and assume just because they're in specific technological area that they will grow higher. Usually it turns out some kind of completely banal type of company is suddenly shooting and is becoming Microsoft of that country, so to say. So there is also econometric evidence. We show that there is no link between high technology sector and high growth firms, and there is a wide range of sectors across all regions where you find high growing firms. So if you are supporting high tech, new technology-based firms because you expect them to be future Microsoft, you are doing a highly risky strategy. You know, it doesn't mean that you shouldn't be doing, but don't have high expectations on that. Much more fruitful way to look at it is not focus yourself on new technology-based firms only, but understand that these are firms which are part of your knowledge system, of your a newly nice fashionable phrase is eco-innovation system or something like that. You know, you shouldn't use word national innovation system, you use eco because it sounds more palatable to some people. So these are firms which are not direct and independent source of growth, but they're important players in the knowledge system. So you don't expect from them that they will be direct source of new product, but they're important as knowledge providers, specialized suppliers, especially for large firms. This is where their important role is. And of course, they require what? Sophisticated markets. That is a crucial ingredient for them in order to be to play a role of knowledge suppliers. I've done some research in Central Eastern Europe about this type of firms. We had samples, and I cannot go now into details, but just I want to give you now a few taxonomies of this firm just to understand what are these type of animals. You know, what are we talking about? So these are this is one piece of research where we looked at the sources of knowledge used in the firm as the basis for product and service innovation. So what is where that knowledge comes from? And on that basis, we do factor analysis and we taxonomize these firms. When you do that, then you have these sources of knowledge. Your source of knowledge can be supplier, customer, patents, research organizations, or in-house. And what you get, you actually very nice, consistent classification. There are 3 types of companies. One of the companies is really those companies which are growing based on formalized R&D knowledge, which means that they're sitting on some patents or on a strong link with the research organization. Yeah, that's what we would like to see. But equally, there are companies which are entirely the major source of knowledge is their in-house, know-how engineers. And there are those where basically knowledge comes from suppliers and customers. They are plugged into value chain, and they're still technology-intensive firms, because these are the type of companies that we have chosen. Or another classification where we classify firms based on their success factors. And these are success factors are listed here on the left, whether you are succeeding because of the management, because of your capability to offer expected services, because of patents, licenses, because of the your government support, because of link with scientific organizations. And again, we have an interesting classification where firms are classified first. One group is really new technology-based firm. This is exactly animals that we would expect to see from the kind of Harvard Business Review, which are firms which grow based, or their success is based on the uniqueness of their product and technology, based on patent and licenses, and based on people and training, what they have. That is one type. But equally, there are firms which are so-called networker. These are firms basically really dependent on public money around. They're dependent on EU funds, on government support, on alliances, on links with scientific organizations. Really, they're dependent on the broader system in which they operate, not on what they're sitting themselves, on what they have developed. But the third type is, for me, the most interesting, because these are firms which are successful because they have something which I call customer-oriented organizational capabilities, which means that they really understand what users want. And they are highly dependent on understanding users' needs. And this is also a very important type of knowledge-intensive organizations. Now, we've done a kind of case studies, and I try to compare these case studies with our archetypical US new technology-based firms. And let's say, okay, let's see how these East European technology-based firms, how they're different from our stylized Harvard Business Review picture. And what you come up with, first, when you look at the mode of growth, new technology-based firms would basically grow through generic expansion based on knowledge that they possessed. Well, in this case, is the productivity-based expansion, which means that you see income growing, revenues are growing at the same number of employees. They're actually not growing very much, but they're increasing their revenue. their strategic objective is not to commercialize the results based on some IPR that they have, because usually they don't have it. It's much more complex type of knowledge in terms of understanding users' needs. So that basically the aim is to diversify to exploit organization capabilities. Usually you find it in IT, where they are in one sector and they can apply that knowledge in other sectors. Model role is not gazelle type of company, which is the dream of European policymakers to have a European Microsoft, but they're basically knowledge broker and specialized suppliers. And therefore, that is their structural position, where they are not oriented towards global market, they are oriented actually towards domestic market. And the threshold barrier in that context when is whether they can go from the position of domestic brand builder and networker to become established exporter. None of these companies is actually from Eastern Europe, even when you look at the Czech Republic, is selling to Germany. No, they're selling to Turkey. No, they're selling to Armenia, they're selling to Russia, but not into markets which are highly saturated and which they do not have recognition and brand. And their competitive advantage is not kind of new world technology frontier product, but the customer-oriented organization capability, understanding the user's needs. So it's a kind of pretty, quite different type of animal. And we've also compared successful and less successful innovators in these countries. This is based on the in-depth analysis of 40 firms. And what comes clearly from this analysis is what distinguishes less successful innovators is understanding of user needs and user involvement, understanding of market. It's not so much R&D, but understanding the market and user needs. Therefore, a lot of these elements which have to do with entrepreneurship and with the external environment and understanding what is there. So, am I doing fine? I still have some time? Okay. So we've done kind of, I painted this broader picture. We've looked at this type of firms in the context of Central Eastern Europe. Let me now jump into this paper which we are completing now, which is on Skolkovo, which is an extremely interesting case, because here is the country which finally, and after so many years, decided, yeah, let's embark on modernization based on new technology. And therefore, Skolkovo is an extremely interesting case. A year and a half ago, we have organized at London a workshop on Skolkovo. We invited people from Skolkovo, we invited academics there, and everything is on the web. You can see the presentations. So this is partly also the outcome of that, because the crucial problem that you can see in the context of Russia is how do you embed the enclaves? There is a kind of paradox there. Because if you want to grow technology-based firms in such institutional environment, you have to do like all other countries are doing. You kind of try to grow them in a kind of protected environment, in a sort of enclave. But there is a paradox there. Once they're in enclave, maybe they will forever stay in enclave. Yeah? Well, your point is that they go beyond the enclave. So you have this paradox. How do you kind of grow through a protected environment, at the same time you would like it to have lots of spillovers? And this is the crucial paradox of it. And of course, Russia has a history in that respect of science cities and so on. And the issue is whether this will be forever enclave, or how do you create, at the end, demand for whatever is there. And there is also a history in Russia of mission-oriented research, where your co-author, Irina Skotter, he said, in the past, when Russia was going for something, they knew exactly when they produced. It was a rocket, it was a launcher, it was a weapon. You knew exactly. In this case, it's very difficult to know whether we have achieved the objective. When did we succeed with Skolkovo? So the way to look at it is basically through understanding what it is about. And the way I would like to think about it, this is actually, yes, it is a targeted policy, but it is a mission-oriented innovation ecosystem idea. And which is quite, again, contradiction itself. How do I have, innovation-oriented innovation ecosystem, but at the same time, I have this idea of a clearly defined target. And all that happens in a context, you have the nature of the state that you have, problem of always behind of possible corruption and so on. But to understand that, again, we have to see more broader. What kind of empirical evidence tells us how R&D contributes to growth? And there is a nice kind of classification by colleagues from Sussex, from Ben Martin and Eamon Salter, who basically look at the literature and understand that there are 6 ways by which R&D can contribute to economic growth. It's not only through increasing stock of useful knowledge, which you would expect, when you do R&D, but it's through training of skilled graduates, equally important effect, through developing new instrumentation and methodologies. A lot of places like Skolkovo will be actually important in terms of developing scientific instrumentation, new methodologies, which are not necessarily new products, to creating networks and promoting social interactions that comes through the whole process of socialization in the R&D system, increasing capacity for problem solving in technological and scientific areas. They're why these companies are actually problem solvers, knowledge brokers, and only then creating new firms. So the criteria by which you want in the future to evaluate Skolkovo shouldn't be only one. Shouldn't be, oh, how many patents we have developed, how many papers we have published, how many firms we have generated. Yes, that is a part of the picture, but you should take this broader perspective to evaluate its potential. No, not in terms of ranking. No, it's just differences. So the way you evaluate it is quite important. That that is the type of answer that you will get. But the point here is that if we want to evaluate really Skolkovo, then we have to also understand that there is a strong mismatch between the public policy which wants to support new technology-based firms and their true nature. And I've summarized here all what I've said before about these firms. And I was pleasantly surprised where just before coming here, I discovered a paper in research policy from Scottish colleagues who basically come to this almost identical conclusion that we came in the case of Eastern Europe. So the story which they analyze, which they come up with in a case of Scottish new technology-based firm, for me is strongly overlapping with East European story. So there is something there. I'm not talking based just on one region experience. And the conclusions are the following, which are applied to their research and our research. First, that in reality, these firms are actually well-established corporate spin-offs, not startups. Most of them are basically, when they're successful. No. This is the general conclusion. It's too early to judge Skolkovo based on these firms. But this is again, if we want to evaluate Skolkovo, we have to take into account what is the true nature of new technology-based firms. Because if you know what is the true nature of these firms, then these are the criteria that you should be using when you assess Skolkovo firms. Because you have to understand that most of these firms are results of corporate spin-offs, not startups. They do not undertake large amounts of in-house R&D. They do not have IPR. They derive their competitive advantage from the knowledge of users, of customers, and many of them are not growth-oriented. So if you are now creating an enclave where you want to be hotbed of new technology-based firms, then your criteria shouldn't be the one of the idealized picture. They should be criteria of the countries which are middle-income economies where you see this type of companies, and these are the criteria that you should be using. So that's my kind of message to why I put it in the context of Skolkovo. Because Skolkovo is something which is Justin Yifulin, which is the former chief economist of the World Bank. He is a godfather of something which is called new structural economics. He would call it high road to development, or the idea that countries want to embark on this high growth through high-tech industries. And when he does research in this respect, then he finds that basically countries are not following their latent comparative advantages, and they are not kind of following something which he calls comparative advantage following industries. So there is a danger always here when you go to high tech that you will be, he would use the phrase, that comparative advantage defying industries. Why? Because you are investing maybe into activities where you don't have all preconditions around. You don't have preconditions for new technology-based competition. You don't have enough sophisticated user. You don't have enough strong domestic demand. You don't have a critical mass. You don't have whole infrastructure which is needed for this type of industries. Therefore, you have to understand what is really the nature of your new technology-based firms. So what I'm pointing here is that policymakers should understand that supporting high technology, new technology-based firms in the US or in Russia is something quite different. And that therefore, the nature of policies should be quite different. And this is if consultants want to find the kind of theoretical support, then there is a kind of Schumpeterian theory which was exactly along this line, where the idea that institutions that favor imitation are not the same as those that are favoring leading edge innovation. The idea is, yes, now if you ask economic theory, then economic theory tells you, that you have to understand what is the technological position of the country and what type of policies you should pursue. You don't have this convergence of policies, but policy has to be highly differentiated. And that's quite important, not only for Russia. I'm talking it because this is my kind of latest mantra in the EU, because EU is actually quite a diversified region in that respect. But we have this convergence of policies in the EU. What is good for Germany is good for Poland. Well, is it good for Poland? Not necessarily. They're very close, but they should have a different policies, But it's very difficult to find the rational, and theoretical argument for that, So that is the point. So I'm coming now to final points. Final points here is that the policies can never be kind of simple policies. Oh, let's put money into specific area. Let's put into this science technology park. Let's put money into people, and then somehow this will lead to it. I've done a kind of more empirical paper where we look at these policies, and with the way we look at the policies, that you have to look at the three types of opportunities. There are technological opportunities, market opportunities, institutional opportunities. That the way to look at the whole situation is a more systemic way. So you don't look at the kind of narrowly at the new technology-based firms, but you are asking yourself, yes, there are technological opportunities because I've got certain R&D capacities. I'm building now this infrastructure, these are technological opportunities, I'm changing law, IPR, blah, 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 but where are market opportunities? So the point is that the policy is always a result of interaction of these three. If you forget one of these, too bad. And that is a kind of, unfortunately, economists cannot come with a simple answer. It's much more complicated. And we should be actually more humble and modest in what we are talking. But that is the kind of main conceptual message. If you want to put it down on the ground floor, and if we are now thinking about Skolkovo, then we should take into account that new technology-based firms are not powerful driver of growth, but they are important actor in innovation ecosystem. And so therefore, if you are evaluating Skolkovo, you have to evaluate it in the context of the overall Russian innovation system and measure its effectiveness, how it changes Russian innovation system. In that case, you have to develop more systemic policies, which will be looking at the support links between new technology-based firms and customers. Who are your potential users? Are you kind of building new cathedrals in the desert? And EU is full of these cathedrals in the desert. So much money spent in South EU, into R&D, where R&D intensity is quite high. Good R&D systems. I'm married to a Greek, so I have some familiarity with the Greek situation, and relatively enhanced R&D system without much link to the local economy. The second element of that policy should be linked between new technology-based firms and large firms. And there is this debate in the economic literature, and actually there is emerging evidence of a strong relationship between the share of large firms and economic growth. And this is something which has been completely neglected. Why? Because they are the major source of demand, and also large firms are the major source of these spin-outs of new firms. When you look at the successful cases of new technology-based firms, then they're usually spin-offs of large firms where there are new technological opportunities, diversification in new technological areas. A third element, enhanced technology demand through public innovation procurement, because in a middle-income economy is where the demand will come from. If you don't have market actors with sophisticated demand, then the state has a legitimate role to play. This is something which is quite neglected instrument in many of these countries. In EU, it's linked to its own complexities because of the free market, single market rules. Countries have limited scope to apply that, but Russia has much more advantages in that respect. And finally, you have to enhance other actors in innovation system. You can't just say, okay, we are doing just Skolkovo and that by itself will be enough. No, because success of Skolkovo will depend whether you have reformed your universities, whether you have reformed public research organizations which are outside of the Skolkovo, because they have to be now recipients, and not recipients, but more active actors to interact with the possible, with this enclave that you have created. So the story cannot stop there, but without changing the other elements, then the effects will be quite limited. So that is the kind of the policy implication of that. I hope I managed to have a thread of the argument. If I didn't, I apologize. You will have to read some of the papers. Thank you.
Slava, thank you. Thank you for your presentation. I would like to take some questions from the audience. First was Daniel.
Thank you. Huh? My name is Dan Satinsky. Yes? What? My name is Dan Satinsky, and I have a history of doing work in innovation systems here in Russia, and have done some work. Previously, we did some research in Perm, in the Perm region, for the regional administration about innovation and how to create an innovation system. And what you described helped me make sense of what we saw and didn't understand when we were seeing it. So everyone in Russia will tell you that the main problem for innovative firms is a lack of internal demand. And this is what everyone says, and it's the main problem for the young firms. When we went and talked to people at the Chamber of Commerce with a region with heavy industry, they bought all their new equipment from Germany. And so no one was going to buy any new innovative equipment from Russian companies. It was all, but it wasn't considered innovation. It was modernization, and so it wasn't measured as innovative activity, and there was a circle that couldn't be completed. And so what you've described helped me see and understand what's going on in it. And I know that the Russian government has tried to force the large industry to buy innovative solutions. And they have difficulty finding those innovative solutions internally, and they have difficulty identifying how to comply with that requirement given their own sort of vertical supply chain, which historically has supplied everything. And then the alternative being buying maybe from Detroit a production line that was more advanced than what they have, but is being disposed of by Detroit. And so what you've described is what I see as a reality, but I'm not sure what the way out is exactly. And because what you've described as a mismatch between very high level research and new startups who they get frustrated with the domestic market and they say, well, our market's abroad. We have to either go abroad or find our customers abroad. And I don't know if you have, I guess others will speak to this. I'm sorry for speaking for so long, but I think really important what you said in terms of a model to understand the mechanics of the system. So thank you.
I want to add to the same debate with one observation. My name is Emanuela Todeva from the University of Surrey. I will go back to your initial point, why firms grow. We know firms grow because of market growth. They can't grow if the market is depressed. So they're always oriented towards the market, and your point about understanding the market is very critical in both internal and external market. But one point which I thought was missing in your conception and probably will add to this debate is the notion of value chains and supply chains. So it's not just the market, it's not just this business to consumer, it's business to business market. These internal links within the economy, what we call the structure of the economy. So if you invest in the agriculture sector, these farmers will need equipment. Some of them will buy from Germany, but some of them will buy second-hand from Russian manufacturers. And this is where actually you recreate this or extend the ecosystem where the innovation firms actually link to the economy, because you create demand within the economy. The procurement method has very limited capability. Yes, it's aiming at very high tech, but what we want to see with growth, we want to see growth through all tech, high tech, mid tech, low tech, basically growing circulation of technologies and development. So perhaps more in this direction of value chains and supply chains, and linking internally and externally to the global economy will actually contribute to the answers.
Me? Okay, I am Elena Rogova from St. Petersburg, and I'd like to maybe reply to Dan. One of the problems, we have made some research on the enterprises of St. Petersburg and machinery, middle-sized equipment, middle-sized enterprises. And one of the problems they underline is about the lack of engineering and the lack of, the quality of mass production of Russian new growth, new technology-based firms. They make prototype, but they cannot produce equipment in the massive market. So this is one of the problems. And maybe I have a question to Slavo. What is about the role of the universities in this process? So we know that universities are the source of knowledge and the source of startups, but what about the engineering, and what can universities contribute to this chain? So this is my question. Thank you.
Thank you. I'm afraid there is no time to answer so many questions, but nevertheless, I have a very Russian question. And now we have not very simple time for Russian high tech because of European sanctions. And now our companies faced with challenge, with absence of a lot of number of components for high-tech production. And under such circumstances, we must think about import replacement. And it is huge discussion here, how to do it. What does it mean, import replacement of high-tech components? And my perception is it is quite impossible to organize total import replacement, and only chance to do it with collaboration with another players in this market for coming to global market. For example, there are good examples of International Space Station. Now we begin to develop new aircraft with China, and so on, so on, so on. What's your view? What kind of policy can be useful for in this case? Thank you so much.
Thank you very much. Thank you very much for good questions and comments. Yeah, this boundary between modernization and innovation is something which would have to be reconsidered. And that's partly because probably there is a strong influence of the science lobby which wants to say, well, this is only innovation. But the boundary is much more murkier. And the notion of innovation policy should be much more broadened. And therefore, then you would bring this kind of hidden innovation. Britain is one of the countries which is full of hidden innovation because R&D is very small, relatively to how rich is the country, but there's a lot of knowledge-intensive activities which are within the hidden innovation. And finally, after 20 years, policymakers have realized, I think it's time for Russia to understand that there is a lot of hidden innovation in the country and bring it to surface, so to say. Yes, value chains, that colleague from Sari pointed, is extremely important, especially for the country like Russia, which is outside of the global production networks. But the experience of Central Europe, which is into production networks, and there is quite known high growth German automotive cluster in Central Europe, which is the source of growth and stability in the region. Actually, the reason why that region survived global financial crisis is thanks to that. But also there are limitations of that. And what research shows that value chains are very good to improve your production capability. It brings you to a level of highly competent supplier. Whether you will grow after that, my question is then whether Central Europe will grow next 20 years is not something which will be simply in the hands of foreign company and domestic company, because that position of the company is, so to say, cemented, limited. Now you have to have a new level of upgrading and structural change where you are going from competent supplier to bring elements of engineering, bring elements of changing your mandate within the value chains. So value chains are indispensable part, and especially for country like Russia, this is essential part now. But going further and ensuring the technology upgrading, then you have to go beyond the value chain upgrading. And that is something where you have to have complementarities between your domestic innovation policy and FDI policy. The way I put it, I said, FDI innovation policy should be one type of policy. They shouldn't be institutionally separated. And this is very difficult. It's simple to say, but believe me, there are very few countries which understand that and are doing something about that. And this leads me to this example from a colleague from St. Petersburg. It's no wonder. It's exactly what I would expect that your institute would say. We develop prototype and we can't ensure mass production. Well, no wonder, exactly because the main problem of Russia is not things which are outside of production. Russia has the capacities to develop on my slide there, this left-hand side. But when it comes to then applying it, it would need one Korea, yeah? Because Korea was exactly strong on that right-hand side, And so this is the kind of Russian problem. And that the easiest way to do it would be through global value chains. This is when it is. But that is obviously, I call it, Russia was doing very much in terms of, I call it, domestic-led modernization. And Skolkovo is an attempt of domestic-led, but it will not succeed if it is not combined and coupled with something which I call foreign-led modernization. Because catching up comes when countries are able to combine these two modes of modernization. It's not just, I open myself, a small country like Estonia was doing like that. I open myself and that's enough. No, even they realize that that's not enough. You have to couple both modes of modernization, and that is again paradox. How do you do it? How do I open myself at the same time, push for domestic technology effort? This is kind of contradiction in itself. But this is the issue which most of these countries are faces. What universities can do in that respect? I think universities is a huge story and huge factor or blockage to modernization in this region. It's not only Russia, but it's the whole Central Eastern Europe. They are not factor of modernization. We have to unfortunately admit that. First, because they have to be differentiated. You need research universities. We are in one of such universities, but equally you need universities which have different functions. You need entrepreneurial universities. You need universities which are plugged into global knowledge networks. You need variety of that, so therefore you have to have a system which ensures that. We are somewhere now in the middle. We are in the worst of the possible worlds in that respect. And there is too much emphasis then of a simplified and primitive view of what that entrepreneurial university means, which means, oh, we just confine it on commercialization. We expect more spin-offs, And forgetting that the major function is, if you look at these contributions of R&D, which I pointed from Martin and Salter, which is the basically knowledge provider, problem solver, much more things which are connections through people rather than expected, oh, we have a technology transfer office and we are sitting now on our 3 patents and I mean, if you look at the US story about that, it's huge disappointment in that respect. It's basically just confined and everything is masked because story is concentrated in few universities and you forget that in the rest of universities there's not much there. So even if you look thorough investigation of the US story, you will come to different examples. And finally, your point from Alexander is about this, how to go in the future about it. You pointed exactly to examples which are the route how Russia would go, and which is for me this kind of coupling between domestic and led modernization. But these examples through these jet companies which are producing, and which are produced how? They are produced in collaboration, in close collaboration with foreign firms. There is no country today which can decide to go its autonomous technological development. There is no country. US cannot do it anymore. So therefore, it would be silly for Russia to contemplate at all in that. So therefore, it is a not only economic, technological question, it's also a political question. You have to have conditions which enable that, which enables the joint development, and then all the strength of Russia would come into that. But there's some point where kind of one can give advice, but there is a political context which has its limits.
Thank you very much. And now we are moving to next speaker, Andrzej Yashinsky, professor, School of Management, University of Warsaw. And the title of presentation is Industrial R&D as a Key to Innovativeness, ? Polish Experience.
When I received an invitation from Irina to her panel, I accepted this invitation with pleasure. Moreover, I have tried to follow 4 questions that she has directed to us, because as I understand the panel discussion, it is that there are some questions. Each of the panelists should answer all questions. So there should be 2, 3, or 4 rounds of speeches. So let me try to answer the first question, which was, what are the key characteristics of new high technology industries? And perhaps I will not tell anything new. What are key characteristics? So high-tech industries are, as we all know, are R&D intensive, usually. They develop very quickly. Their products and services are exported, are very well easily exported. And now let me stop. Can you switch? Yes. Let me stop with first issue, the issue of R&D within firms, and then afterwards there will be a comment to Slavos' paper. Sorry. Okay. So a crucial significance of R&D within industrial firms is result of at least three reasons. Firstly, when conducting R&D inside the firm, then the continuity, kind of continuity is being kept between its R&D activity and the innovations appearing in this enterprise. Secondly, as known, people like best to implement their own ideas and not somebody else's ideas. For example, those ideas born in external public, for instance, public research organizations. And thirdly, R&D carried out in firms usually has a character of applied research and experimental development that, as we said, stand closer to the market than R&D run at universities and other research institutions. A key role of industrial R&D, I mean R&D in industrial firms, from the viewpoint of the level of firms' innovativeness, results also from the fact that technological change in a firm is an effect of its own innovation and of an inflow of a new technology, embodied or not, from the outside as a symptom technology transfer. And now I would like to add one comment. I was impressed by Slavos' paper. Yes, it is very crucial that the companies should have absorption capabilities. It is not so easy to offer new technologies to firms or by firms to buy, but for instance, very many Polish firms do not have enough absorption capabilities to absorb new technologies. As we know from the past, you know, in the 70s, we had the best decade in Poland. The best decade in Poland, never repeated again. Speaking about how many Western technological licenses Poland bought. And what happened? Almost nothing, because Polish enterprises were not prepared to implement, to use these new technologies, no, not high technologies. So a firm's R&D activity is favorable to, firstly, the growth of its capacity to generate innovation and the ability to absorb new technologies from the market. We can find in literature, for instance, according to my friend, as we know each other, John Besant and Joe Tidd, frankly speaking, and Keith Pavitt in the past, because the original of this book was Managing Innovation. Managing Innovation was prepared by David Besant and Joe Tidd. So the other arguments for a big role of R&D in a firm's development are two elements. I'm not going to repeat what you can see on the screen. So their arguments are based on empirical research in among British firms and American and other. So three other arguments. Within the last several years, I exploited in my publications and in my research projects, I exploited a thesis that to have more innovation in Poland, we need more R&D effort within firms. I mean R&D spending, R&D performance within firms. And I remember the title of my paper for a conference 4 or 5 years ago was a key role of R&D in industrial firms for their innovativeness. When I prepared a paper for this conference, I put a question mark at the end, whether this is a key role or not. Because according to my latest research results, unfortunately, it didn't happen. So Polish enterprises received huge amount of money within structural fund, European Union structural funds. Polish companies received much money for R&D, for innovation, and according to the latest statistics, if we can compare, taking the previous financial perspective, I mean 2007, 2013, and I have data for, let's take these two poles. So now, in Polish industrial firms, because I spoke about industrial firms mainly, there are many R&D workers working there. Polish R&D companies spend more money on R&D. I mean, the percentage of R&D expenditures within innovation activity, within expenditures on innovation activity. But we made no progress in innovation. So, frankly speaking, I'm waiting for the latest data because, you know, there is a time lag between R&D investment and results. I mean, by which I mean innovation, technological innovations. So we need, say, 2, 3, maybe 4 years. So I expect that, you know, very many technological innovations will appear, say, in recent years. And this is a confirmation of what Slavo said, that this is a complex issue. This is not a simple thesis, simple problem. Put more on R&D within firms, as I used to expect, used to say in the past. But as I say, there are many other circumstances, I would say circumstances, circumstances needed, or conditions, yes, stimuli, circumstances needed for enterprises to be more innovative. For instance, as I said, absorption capabilities, more. Technology transfer between firms. You know, according to the latest data, the level of technology transfer between firms is very little. So and other circumstances, FDI policy, etc. I do not have time to speak more. So the main reasons for still small R&D effort in comparison with Western, with companies in highly developed countries. So the lack of free financial resources, which is when you do a questionnaire, all firms will always complain about lacking financial resources. Underestimation by managers of a key role of the R&D investment for the firm's long-term development, confirmed in our empirical research. Then entrepreneurs' natural fear of a risk, or of a big innovation risk. That is an immanent feature of innovation processes. The lack of own R&D facilities in numerous firms as a legacy of the past, not only in small and medium-sized enterprises, and a slight public financial support for industrial R&D. However, there are some broader, general, I would say, structural imperfections in the national economy which should be taken into account while creating public innovation policy. So the lack of well-functioning R&D and innovation markets, you can see examples. Improper location of the R&D potential, as I mentioned in the past, far from the market. I mean, in universities, 85% of Polish R&D potential is localized outside firms, in universities, Polish Academy of Sciences research institutes, and other public research and private institutes. Then, insufficient cooperation between the R&D sector and the business sector. which we always complain, not only in Poland, and the lack of innovation culture in enterprises. I think this is a very important issue. So I think that these are at least answers for a first question. If I still have a microphone and I may use a couple of minutes, yes, for trying to answer this question. The second question was, if I may, yes, what do new industries change most of all in the relationship government university industry? I would like to say three things. Firstly, high technology industries may be treated as locomotives of the business sector development, and this is perhaps nothing new. Second, high-tech industries may help the functioning of the education sector by offering new technologies, new equipment, new scientific instruments to universities and other higher education institutions. And three, high-tech industries may help the functioning of a public sector, for instance, by participating in public procurement bids, so via public procurement. So, as you can see, it is connected with a triple helix, relationships within the triple helix model. Thank you, Slavo. Third question, what are the country differences in regulation and government support for new high-tech industries? And also, I will refer to Slavo's paper also. I would say, based on Polish literature, scientific literature, for instance, I can see that there is a kind of fashion, or a kind of fashion on high-tech industries has emerged. That all are speaking about high technology, high-tech firms, high-tech industries, and etc. However, low-tech industries also need technological innovations. This is quite not a new thesis. For instance, in Poland, we have a big share of low-tech industries in economic growth, in GDP, for instance, food processing, furniture, clothes, shoes. These industries need innovation, technological innovation, also, maybe even more, because these are, to some extent, Polish specializations. Furniture. Poland is one of the biggest furniture producer in Europe. Food, not as tasty as in Russia, but also tasty. Yeah, in Russia, you didn't spoil food as much as we did in Poland. But now I can see a kind of restoration and return to natural food production in Poland. So I would stress that we, in Poland, for instance, we need technological change, both in high-tech industries and also, maybe even more, in low-tech industries to modernize this. Thanks a lot, Irina. Little time left.
Yes, actually, yes, we don't have much time, so I would like to invite Kelvin Bilubi And he actually works at Skolkovo Institute of Science and Technology, not at Skolkovo Fund. About, I guess, Slava talked more. But it's again part of ecosystem of Skolkovo. And Kelvin should give us, I assume, specific example, United States and bioscience-based industries. Thank you.
How much time do I have? 20 minutes. I'm an American, but I've moved to live in Russia at a very exciting time, at a very exciting university, Skolkovo Institute of Science and Technology. I'm going to talk about something I know about, which is the bioscience technology industries in the United States. I want to say something about the United States that not everyone recognizes, which that it is, unlike Europe, which has only about 30-odd countries, the United States is comprised of about 50-odd countries, states. Each state in the United States is a sovereign state in a kind of commonwealth. Each has its own government, its own policies, its own taxing system. It's a complex mess. Easier to manage than Europe because there is a single US government. But nevertheless, it's important to recognize the diversity of the United States. So I've worked in various capacities with universities, industry associations, government bodies in these states in the United States. Typically when we think about high technology industry in the US, we're thinking about so-called Silicon Valley. I've worked there also. You can see California on the top of the list. But I find other states to be more interesting. Minnesota, Utah, and New York State, where I've done a lot of work. These are not the typical places you hear of as high-tech regions. And I think some of the lessons we can learn from these states are very similar from what Professor Radesevich and Professor Jasinski were talking about with the Eastern European countries. So let me just tell you humbly a few things that I've learned from these places. I also should point out that the Triple Helix isn't working properly everywhere. Sometimes success comes without Triple Helix. Sometimes you have Triple Helix without success. So let me give you a couple of examples. Now, when I talk about the bioscience technology industries, this is what I mean. I've done some very rigorous census work and empirical work in these states, in these industries. This is my way of defining these industries. In some places, this is called the life sciences. That's rubbish. It's not the life sciences. It's technology industries linked to the life domain in some way, drawing upon life sciences quite often. Sometimes it's called biotech, but biotech also is a narrower group of things. So I won't go into this, lack of time, but this is the domain. If you're interested, I've analyzed this very rigorously and I have some papers I could share with you about it. I'm going to start with some ideas that I've picked up. Bear in mind, I've been working with industry associations and government bodies at the state level and the county level and the city level, and I've picked up some common ideas that are believed in, orthodoxies about economic development and high technology industries. Here they are. And first one, it's a kind of a theme, an assumption. Expensive resources stop the development of high-tech industry. That means if labor costs a lot, expensive skilled people, if land costs a lot, if raw materials, transportation, access to educated people, etc., then it's a problem. Secondly, the idea is high taxes stop high technology companies from coming to our town. A third idea is that regulations, strong regulations, are an impediment to high technology industry development. The next one, the favorite of all, venture capital. I think every respectable management consulting firm has earned multiple millions of dollars going to California to say what's the secret of success, and it's usually venture capital. Then you look at our town and it's usually there's some structural reason why we don't have enough venture capital, therefore government should subsidize the venture capital sector in our town. That's a very popular idea, and it's based on this assumption that shortage of venture capital is the main impediment to development of high-tech industry. You recognize these, right? The whole world thinks this way, except our learned scholars on the platform here. The other idea is that we need to attract high-tech firms from somewhere else to come to our town, or our state, or our region, or our country. And then finally, there's another idea that to succeed in building up say a high-tech cluster, we need one or two anchor firms that are big to act as a kind of magnet. I've seen these ideas again and again, and various policy solutions come as a result of this kind of analysis. Subsidize local firms by subsidizing land, tech parks, cheap subsidizing people, etc., etc. Reduce taxes. Take your firm to our town. You'll have a tax-free holiday for 10 years. We have no regulations. You can dump your stuff out in the backyard and we won't ask questions about it. Subsidies for venture capital. We do all kinds of things to help your firm to move to our town, our country, our state and do well. And we also try to get big firms to anchor here. Okay, I think most of those ideas are misplaced. They're very popular. Almost every place I've been to in the United States tries to follow these policies. They're a waste of time, is my simple view. Because of lack of time today, I won't give you the full explanation now, but let me give you some evidence from my own research in these several states in the US for this. So my heterodox idea that lowering the cost of resources, through subsidies, whatever, I think it won't necessarily bring about improvement in the development of high technology industry. High-tech firms don't need low costs, is my opinion. Let me give you an example here. This is from the same set of industries that I've just talked about, a shift from late 70s to the early 2000s in these states. Now, Minnesota was where I was doing my work at this time, and we were interested in other states in the United States against which Minnesota competes. And you'll notice California is the big one here, understandably, because of the so-called Silicon Valley phenomenon. During this time period, the popular business press and most of the policy analysis were saying California's time is over. It's too expensive to do business there. You tried to buy a house there, tried to set up a factory, you realize how much the land costs. You tried to hire anybody, you realize how much money these people want to be paid, and those damn environmentalists and anti-technology activists, they've got all these rules and regulations. It's at the state level, the city level. It's a disaster. So forget California, set up your firm in some cheaper place where it's a more attractive business environment. But look what happened. During this time, when everyone was saying California's days are over in this industry, it grew dramatically, numbers of jobs in these firms. The increase alone in employment in California is about the size of the largest population of employment in this industry in any other state in the US. Okay, the simple message here is that high costs are not an impediment to growth in these industries. And you can see the states that generally thought of as more attractive because of their better business environment for these industries didn't grow as much. Okay, next idea. Cutting taxes will fix the problem. Well, here's some data from New York. And this was some, basically there's a number of questions I asked firms there about how advantageous is your current location in New York for doing research and development in bioscience technology. And you can see at the top there, cost of doing business is, they say New York's a bad place to do business. It's very expensive. Most firms say that. But advantageous are these other points here. Availability of good people, good support staff, and universities, proximity. So what you're seeing in New York is that, yeah, it's very expensive, taxes are high, etc. But actually other things are more important to them. Now, this is manufacturing. You can see here that the cost of doing business, it's very important to them. And yet these other things, I call the people and the knowledge factors, are even more important. And you've got, oh, that's R&D. Okay, you get the point here? Yes, cost matters. All firms complain about it, but actually it's not a driving force. Other things matter more often. Okay, regulations. Here's some data from California, the biotech industry, late 1980s. And you can see the firms say California is a lousy place to do business for the point of view of regulations and the cost of land, basically. But other things are more attractive. So in short, regulations, onerous regulations and high costs, everyone complains. They're a problem, but big deal. It doesn't matter. Here's some similar information from California. Now, it's important to recognize that biotech isn't just in the United States or Poland or Russia or UK. it's in particular places, particular states, but also particular sub-regions of states. And I divided up both California and New York. I've done some other work into sub-regions, and you find very different dynamics in the way that people factors, cost factors, knowledge factors, agglomeration dynamics work. So the locality is very, very important. And you can see here that the importance of the question here was what determined where you're located. So regulatory environment matters, but it's much lower than these other things I've talked about, people and access to universities. Access to money, not very important. If you're thinking of trying to persuade the taxpayers of your place to subsidize foreign firms, forget it, it's a waste of money. Okay, I'll skip this one. It's a similar argument for manufacturing. Venture capital. You heard the argument. Our town is not doing well in high tech because we don't have a local venture capital industry. Therefore, taxpayers should subsidize venture capital firms. Well, I found out through my research that I've done several studies looking at this in several locations. Venture capital is usually only a small proportion of the funding for high-tech firms, less than 10%. Here's some data from the firms I've just shown you. This is from Utah and New York combined. Roughly 80% of funding in the high-tech industry comes from what I call bootstrap financing, which among other things includes cash flow financing. Here's some data on difference between receiving venture capital funding and not receiving it. Simple story is, if you receive venture capital funding, you won't perform as well financially. That's a long discussion in its own right, but just take note of that and we'll come back to it later if there's time. All right, let's attract foreign firms. Most places I've been, there may be some enlightened policymakers who begin to think about these things and want a more sophisticated approach to developing a local high technology industry. And so they begin exploring different subtle approaches. And then there's this possibility that 3M will relocate, or Genentech will set up a plant, or maybe Apple will do something in our town. So drop everything, we'll spend $10 million to induce them to come and visit, we'll give them a tax break. I find it's this annoying problem that policymakers drop sophisticated policy as soon as they smell the possibility of attracting a firm from somewhere else to relocate. It usually fails. Even if it succeeds temporarily, the firm just screws the local economy, takes the taxpayers' money and disappears after a couple of years. I'm exaggerating to make the point, but it's very... Anyway, here's some data from Utah. I found 95% of the firms there founded in Utah, and 89% the entrepreneur was in Utah when the firm was founded. So in other words, firms in this industry are homegrown. I have 5 or 10 more minutes. Okay, this is data from New York. I worked in New York State over a period of about 10 years, looking at initially the biotech industry, then this broader array of industries which I call bioscience technology. And you see in this time period, there was a huge growth in employment in this sector. This is just biotech firms, actually, that's narrowly defined, in Long Island. What's going on here? And I want to stress a couple of things. Firstly, high-tech industries are very localized. They're not national, usually. Very localized. We're not even talking a state. We're talking a locality, the size of a city, roughly, or a region similar to a city. That's where high-tech development actually happens, and where a lot of the policy has to be formulated. So Tomsk is an appropriate region, more interesting than Russia. Skolkovo is a region more interesting than Russia, although it's integrated with Russia. And I recognize all of the issues you raised. Okay, so something extraordinarily happened in Long Island. What was it? Well, there's a couple of things. Unfortunately, I couldn't find all of my slides to explain this, but I'll give you a couple of bits of information. This shows you that Long Island is the most diversified. It has variety of industries and fields of technology related to the life sciences. So diversity of technological capability, market orientation and product capability is one factor that leads to innovation and employment growth. The next thing is to do with what we sometimes call open innovation. Let me jump ahead and tell you the punchline here. The key to employment growth and entrepreneurial success and growth of entrepreneurial firms in this sector, bioscience technology, is vigorous informal communication between people inside the firms and a broad range of organizations and people in the locality and elsewhere in the world. That's the punchline I want you to take away from this talk. And you can see it here in this slide. This is New York data, biotech industry only. What I did is I have a measure of performance. It's a revenue-based index. We'll talk about it later if you're interested. I measured the degree to which firms are engaging in joint ventures and formal collaborations with firms locally in the neighborhood, elsewhere in the US and internationally. I also measured the degree to which employees or people in the organizations are engaging in talking. Informal communication is the academic word for that, talking. And what it shows you here is that firms that engage in above average levels of informal communication with the outside world have higher revenue growth performance. Firms that have above average levels of formal collaboration doesn't seem to have a big impact. Informal matters. You can also see it matters mostly at the international level and the local level. In short, if a firm is going to flourish, its people need to talk a lot around town and to people in other countries in relevant fields. Same kind of measure. This is New York, but about 7 or 8 years later, with a broader range of technologies and products and industry areas, still in bioscience technology. You see the same pattern. The red is firms that have high levels of informal communication worldwide, locally, and nationally. They outperform those that don't. It turns out by later in the decade, those that are engaged in collaborations also outperform others. Similar data, you can see here that the international level makes an extraordinary difference. And I think this gets back to some of your comments about firms in Russia. What about the domestic market? Is it weak, strong? How do we build up better relationships? This is American data, it's New York data in particular, and a lot of this is from not New York City, but for less dominant parts of New York. Connecting with the rest of the world helps this place develop. Now, we're not talking Silicon Valley where the whole world visits there automatically. This is people from these firms reaching out to the rest of the world. Does it apply here? Maybe we can talk about that, but it applies in non-dominant states in the United States. Similar information. This tells you that biotech firms are more R&D intensive. The more scientific, more R&D intensive a firm is, the greater the positive impact on business performance through engaging in informal communication. All right. I better speed up a little bit. Next point, little firms are the driving force here. Vast majority of firms are less than 25 people, a full quarter less than 5 people. Little firms make up this industry. Now, there are some big players, and they're important in the whole, should we say, ecology, but little firms are big players. I've got some data here on incubators and tech parks in Maryland. I'm going to skip that, but the story is the same. Having a lousy business environment, by that I mean high costs, high tax, lousy regulations, is irrelevant. Firms complain about it, it's a problem, just get used to it, that's life. What matters is the culture of communication locally and internationally. I found this in Maryland as well. Okay, let me go to your favorite state and mine, Minnesota. I'm a citizen of Minnesota. I've done a lot of my recent work in Minnesota, and I showed you some data from there before. So this shows you, Minnesota and 10 other states, how employment levels are in this sector, bioscience technology, over this time period from late 90s through to late 2000s. Once again, California dominates. Minnesota's got slightly better. Some other states have changed. This is tough times in recent years. There's been a global downturn with the global financial crisis. It affected this sector, but I heard a presentation yesterday, somebody said the growth of high tech is linked to the growth of the whole economy. Yes, but not rigidly so. It varies from state to state. Okay, another thing that's important to recognize here is this state, Minnesota, has a very active Triple Helix complex. Government, industry, universities, hospitals, and I was part of that group. So a lot of this data I'm showing you comes from my involvement in the Triple Helix experiment, shall we say. All right, what I've done, you can see California dominates, but of course, California's got a huge population, more than 30 million people. Minnesota has only 4 or 5 million people. So you can standardize these figures. I've developed an index, I call it an employment density index. It standardizes the size of employment in an industry in a region for the size of the population. And you can see here that, so this red line means you're average. You're about the level you should be if you're doing okay. And you can see Minnesota was fairly strong, then it got weak and it got strong again. California's staying, it's way above average. It's 1.5 times how strong you'd expect a state to be, all things being equal. Massachusetts, interestingly, has got stronger. Utah, where I did a lot of work, has got weaker. Utah had a very strong Triple Helix complex in the mid-90s, early 90s. It declined. I think it's simply a matter of leadership and people. I've got just a minute or so to go here, a couple of minutes. This is enterprises. This shows you that Minnesota is was below average, it improved. California stays about average, declined a bit. Washington State has increased. Massachusetts is doing very well. The short message here is that states that have high cost, difficult regulations can do quite well. Also, leadership and effort in the Triple Helix model can make a difference. This trend you see here with Minnesota getting better, I know from local experience, is because of efforts, cooperation and leadership in the local community. All right, this is the same information expressed in percentage changes. So you see here some states have deteriorated. New York, Utah, the leadership, the Triple Helix complex has deteriorated during this time. Minnesota deteriorated for some time, learnt its lessons and got better again. In short, leadership in the Triple Helix system can make a difference at the local level to an industry. Okay, what are the lessons we learn here? Run out of time? I've got some diagrams that may elaborate on this, but let me stop here. You got the picture? The usual formula for success in economic development and business growth in high tech is rubbish. Most of the tempting formulas that most local governments follow don't work. What really matters is firms connecting richly and vigorously, informally, with a range of people and organizations locally and internationally. What can a government do? What can a Triple Helix community do? Facilitate this. So whatever money and policy initiatives a government might take should be oriented to facilitating the creation of what I call a local technological milieu, connected with other milieu elsewhere in the world. That's how money should be used, not tax deductions, not subsidizing venture capitalists, not getting rid of regulations, not lowering taxes. Thank you very much.
Thank you. Questions?
Yeah, it's partly a question, partly a comment. It's related to what you said about the cost of resources, cost of labor, if you like. I have a slightly different take on that. In Norway, we have a very compressed wage scale, which means that highly qualified labor comes cheap, manual labor is expensive. So what kind of business would you like to run? I think the incentives for businesses are very strong, and as it turns out, we have one of the highest degrees of labor productivity in the world. So then you might think, okay, the bright people will go away because they can make more money elsewhere. But in fact, they don't, because they want the Norwegian welfare state. They want free, high-quality healthcare. They want kindergartens. They want generous paternity and maternity leaves, and so on. I mean, this is partly a political statement, but I still wonder if you could comment on that. Then I have a different question or comment. It's related to what Professor Radoshevich said about the difficulty of classifying firms as high-tech and low-tech. I'm going to say more about this later, but I could have used the oil industry as an example, because if you classify R&D intensity as the percentage of their income which is spent on R&D, they come out very poorly because they make so much money. But in Norway, the second biggest export industry is fish farming, which is also typically low tech. But the reason why we could build these cages that can withstand the harsh conditions of the North Sea is that we already had the materials technology from the oil industry. The University of Tromsø had done basic research on fish diseases, which nobody was particularly interested in, but then suddenly it became very relevant, and so on. So it's embedded R&D. Yeah, thank you.
Thank you for those comments. Well, I think partly your comments about Norway reinforce a basic point, which is high costs of labour aren't a big impediment. And your point that Norway has a kind of cap at the upper level, that's an interesting one I haven't thought about deeply. I guess if people are in Norway, they love being in Norway, and they're embedded in the local milieu of Norway, feeding upon the industries, the context, the culture, the market opportunities, then salary doesn't matter that much. As I've seen in these states in the US, the entrepreneurs come from local neighbor community, and they like to be there. So if there's a strong relationship with the community, then the salary is a minor issue, I think. Something that we need to explore a little bit more. Fish farming is certainly not low-tech. I spent a couple of years in Thailand, and aquaculture is big business there. It's very sophisticated with disease control, diagnostics, management of ponds, breeding, etc. It's very sophisticated technologically. Sorry? Thailand? Oh, Norway. In Thailand, there's some big private companies that do a lot of in-house research, and there's public institutions that do it as well. So I agree with all of these comments. This high-tech, low-tech distinction, it's not very meaningful. I defined these industries by the field of technology, and all of the firms have the majority of their work devoted to business in that field of technology. But whether it's high or low, that's a confusing question, I think, yes.
Okay, last question.
I would like just to offer a comment talking about industries, because what I do, I dissect industries, and I have done research on in the UK, the medical technology, and I identified two different R&D segments. One which is pure R&D, and the other what I called R&D support sector. And very clearly, the R&D support performance is much better because they support the R&D. The venture capitals give money to the R&D. The R&D support provide laboratory equipment, testing of components, training, services, and they extract more from the venture capital, and the R&D firms themselves have a very poor cash flow.
Okay. Actually, since it was about venture capital, I was interested to hear that you found that venture capital has very moderate effect on the performance of the firms, but were you talking about which size of firms, like average? Maybe I missed, or it's only about small firms? Because sounds very strange.
The data I showed you about venture capital, both the percentage of total financing for the industry coming from venture capital sources and the impact of venture capital on performance of firms, it's the whole population of firms I'm talking about here, all size ranges. It turns out a lot of the bigger firms started smaller and received venture capital in earlier stages. It's been part of their formula. And the way venture capital firms work nowadays, they're no longer venture capitalists, they're just capitalists. Most venture capital firms are not interested in you unless you don't need them. And you must be at a certain scale of operation, already profitable before you'll even get a knock on the door from a venture capitalist. So angels and other sources of funding are more important for startups and younger firms now. But in short, it's the full range of firms, and a big firm in this industry is like 150 people or 100, sometimes over 200 or 300. So venture capital is even relevant for the bigger firms. So my simple view on venture capital is it is sometimes very important and the most appropriate form of financing, but only sometimes, and that's less than 10% of the times. So one of the skills that's needed for entrepreneurs is to know when it's appropriate and when it's not, and for public policy people not to waste too much time trying to subsidize venture capitalists who are perfectly good at making money without taxpayers' help.
So that's, we're already out of time. It's the end of our panel. We are not specifically answering the questions which were outlined to the section, but I think that topics which were raised and new questions which appeared are new and important. And for example, Slava, I guess, raised even more questions that gave answers. For example, how it may be combined all this trend to customer orientation and at the same time for economies which are mission oriented and very strongly hierarchically constructed, like Russia, for example, and some other countries. That's the problem, and that's really the problem which we will face while new industries are developing. Also, I think was very interesting about not direct connection, which was stated in Slava and in Andrzej, between that high-tech R&D expenditures and productivity and growth, because always it goes without saying, more R&D, better everything. And if you cannot even measure direct contribution, then it is there and it's always important. Now we see that a variety of cases is much bigger, which leads to economic success. I think especially interesting was about Skolkovo, since here we are in Russian audience, and Skolkovo is it still continues to be an issue, and Skolkovo and Skoltech and how it does, and how to assess its performance. And I think for me was sort of discovery. I didn't think about that. Again, what Slava said about difference on spin-offs and startups. That, if I understood correctly, if spin-off show better performance and are in longer run more productive than startups. So startups is a weaker indicator of success. Is that correct?
Yes, because you have the high probability of failure.
Yes. So then it's like advice for those who wants to measure Skolkovo performance, to look on different types of these small companies on their origin and how the different results is. So thank you very much who were here all the time, listened and asked questions, and we'll see each other in next sessions.